prove that if G is a group and A and B are elements in G, then the equation AX equals B has a unique solution. So let's go ahead and go through the proof. So proof. So this is an existence and uniqueness proof. So we first have to show that there is a solution, that's the existence part, and then we have to prove that it is the only solution, that is the uniqueness part. So just to point out that a solution to this is going to be A inverse B. Okay, because if this is our X, then we have our A here. Well, basically these will cancel and we're just going to get B. And so this will satisfy the equation. So we just have to justify that this exists, and then we have to show that it is the only solution. Okay, so let's go ahead and first explain why it exists. So note, since A is in G, and G is a group, so it's closed under inverses, and G is closed under inverses. That's one way to say that that's one way to say that every element in G has an inverse. You can say it's closed under inverses. A inverse is also in G. And since, really pedantic here, since B and A inverse are in G, and G is closed under the group operation, right? There's a binary operation defined on G. G is closed under the group operation. Again, just being really precise here. We have that the element A inverse, I'll call it X. Well, let me just say A inverse B is in G. So, I mean, this is something that might seem obvious to some people, but I think it's important to understand everything. And that's one of the things about mathematics that is important. You're supposed to understand every single step. So the element A is in G, and G is closed under inverses. That means that every element in G has an inverse. That's one of the criteria for G to be a group. So therefore, A inverse is also in G. Another criteria for G to be a group is that it has a binary operation defined on it, meaning that whenever you have two elements in G and you take the product, we call it the product of those elements, that product is also in G. Now, in different groups, the product might be a sum, but we just call it the product when we're speaking in generalities. So in this case, A inverse B is also in G. So now let's go ahead and set X equal to the element A inverse B. Okay. Now we're going to show it's a solution. So then let's plug it in. So AX equals B is our equation. I'm going to switch colors. So we have AX, but that's equal to A inverse B. But this is equal to A inverse B. And this is because of associativity. So this is by associativity. Okay, that's because multiplication in a group is associative. And then this is equal to E, B. And this is because A inverse is the inverse of A, right? That's what it does. When you multiply A inverse by A on either side, you're going to get the identity. So this is because A inverse is the inverse of A. And then E times B is equal to B, and this is because E is the identity. That's the definition of the identity. So because E is the identity. And again, just justifying every single step. So we've shown that it's a solution. So thus, let's just clarify that. So thus, X equals A inverse B. is a solution to the equation ax equals b. Right? So something that, if you look in a textbook and you look at a proof of this in a textbook, it might just be like one sentence or two sentences. And I think it's up to you to really understand it and really fill in everything. And it really isn't hard, but there is a lot of like little details going on behind the scenes that you should be aware of. So now we have to show that it's the only solution. So to do that, what we can do is we can just create another solution. And like suppose there's two solutions and show they're equal. So suppose that x and y are both solutions to the equation in question. Let me just say in question. My handwriting is deteriorating. I'm writing a little bit fast. It est. What we mean by this is that we have ax equals b and ax equals y. Let me switch to a more fun color. Let's go orange. Ax equals b and ay equals b. Well, if ax is equal to b and ay is equal to b, that means that ax is equal to ay. Thus, ax is equal to ay. And at this point, you can invoke the cancellation property, or you can do it manually. Usually, by the time you show this, usually the cancellation property is already discussed. Let's go ahead and pretend we don't have the cancellation property, and let's just do it all from first principles, from scratch. So since a inverses in G, we kind of already established that already, but I'll just, right, because it's closed under the inverses, we can multiply both sides of this equation on the left by A inverse. We're basically doing the same thing, very similar thing that we did. Well, not the same thing, a little bit different. But now we're going to use associativity. So this is A inverse A. And you know, the more you do it, the better you get at it. So it's worth doing it. A inverse A, Y. And so this is by associativity. Right, invoking the fact that the operation is associative, right? The binary operation on a group is an associative operation. Not necessarily commutative, but it's associative. And then we know that this is going to be the identity. Very similar. And so this is again because A inverse is the inverse of A. And then the last one shows us that x equals y. And this is because E is the identity. So we've shown that whenever we have two solutions to this equation, they're in fact the same solution. So basically, we've shown there's only one solution. So thus, x equals A inverse B is the unique solution to AX equals B. There's other really important things in mathematics, theorems, that are existence and uniqueness. For example, the division algorithm is a really big one. That's an existence and uniqueness proof. The statement involves existence and uniqueness, and there's others as well. But that completes the proof, and hopefully this video has made you just a little bit better at just working with basic group theory. Yeah, kind of a fun problem. And again, just really going into the details here and just explaining every little thing. So hopefully this has helped someone out there. Good luck.